Hi all, this is the intro video for function notation. Hopefully we've seen some function notation before, but we're going to go ahead and try and start from scratch and make sure everybody's on the same page with this. Pre-Calc is all about functions. Pre-Calc 1 is a functions course, and Pre-Calc 2 actually is pretty much as well, trig functions in particular, but still a functions course. So we want to make sure that we know first some of the vocab that goes with functions, and then a little bit of the notation stuff, and that's what this video is working on. Okay, so variables can be related in many ways. This is true. Generally, in this course, we're going to be trying to relate two variables, but it's certainly possible to relate three or more variables as well. So for now, thinking about trying to relate two variables. You can describe a relation in all sorts of ways. In particular, we're going to look at describing a relation with words, just explaining in words how two things are related, describing a relationship with a formula or a table or a graph. Those are the big four that we will spend a lot of time looking at. A function is just a particular sort of relation, so a function as well can be described using words, formulas, tables, graphs. And we want to be able to identify whether or not a function is a relation. So the rule that we're going to go with here, this is kind of a working definition of what it means to be a function, is the exactly one rule. So if you are working with a relation that is in fact a function, you should see that every input is associated with exactly one output. So this actually tells us a couple things. One is that a function makes an input-output sort of relationship between two variables. So you'll have an input variable and an output variable. The other is that if it is in fact a function, if you choose any value of the input variable, the function should relate it to exactly one value of the output variable. So we are in big trouble if we pick a value for the input variable and it gets paired with more than one output variable. It's actually not good if it doesn't get paired with any output values, but that one's easily gotten around, so we don't worry quite so much about that one. Okay, so this is what it means to be a function. Every value of the input variable gets paired with exactly one value of the output variable. The other little piece of vocab in here is domain and range. We can't really talk about functions without talking about their domain and range. So the domain of a function is going to be the set of all possible inputs, and the range is the set of all possible outputs. So all possible values of the input variable make up your domain, and all possible values of the output variable make up your range. And you just want to make sure that you remember which of these words is which. It's definitely fair game for me to ask you for the domain and range of something, and you have to remember which one of those is inputs and which one of those is outputs. Okay, so on to a little bit of notation stuff. We have this y equals f of x notation, and these variables are really commonly used in this notation. Here, x is the input variable, y is the output variable, and f is the function name. There is no rule that says y has to be the output variable, or x has to be the input variable, or f has to be the function name. We can use whatever variables we want, but this is really traditional, so we'll start off here. Again, that's read y equals f of x. You want to be really clear on the fact that this is function notation. This is of. Plug x's into function f to get out y's. This is not f times x. It's kind of a weakness of this notation that it looks the way we would write some multiplications. So you have to take the context of the problem and make sure you think very carefully about whether you're multiplying or inputting. So yes, again, this means that y is a function of x. Or basically, if you input a value of x into function f, it pairs it with the output value y. This tells us as well something about what's going on when we graph these things. So if you're trying to graph a function f pairs the input 3 with the output 11. So it's actually fairly similar to saying function f goes through the point 3, 11. And this sort of notation, writing as an ordered pair, does give us the input-output pair, just like function notation, but it doesn't give us the added piece of information of which function did the pairing. We could certainly be working with more than one function, so we could also have function g that pairs input 3 with output -2, and we can very clearly state input-output pairs and also what function paired those inputs and outputs using function notation. So sort of just another little piece of vocab dependence. This is basically what we just talked about. If you are trying to graph, you always want to put your independent variable on the horizontal axis and your dependent variable on the vertical axis. So when we're looking at function notation, we've already said the output variable goes vertical and the input variable goes horizontal. So just a way that you can say this to yourself. If we're saying y is a function of x, that's somewhat interchangeable, at least for now, with saying that y depends on x. As soon as you can say that y depends on x, it's fair to say y is your dependent variable and x is your independent variable. Okay, almost done here. One last thing, and this is a big one. It might look kind of new, but it actually is something that should be familiar. It's just written with function notation, so it might be hidden from you for now. Average rate of change, I'll abbreviate this AROC. Function f from x equals a to x equals b is given by f of b minus f of a over b minus a. Okay, so this might look like a big, huge mess right now, but if we pick it apart using what we just talked about, we should be able to spot something familiar in here. Remember, we just said that whenever you see f of something, you're talking about a y value. So on the top of this fraction, I see a y value, f of b, minus another y value, f of a. So if you think back to when we would have something like this, a y value minus a different y value, or maybe you want to think a y2 minus a y1, I hope that slope is coming to mind. So when I look at the top of this fraction, f of b minus f of a, I am seeing rise, change in y value, the difference between my two y values. In order for this to actually be slope, we would have to divide rise by run. So we want to think carefully about this. The run should be the change in your x value. And notice we said this was from x equals a to x equals b, or we can even see it up at the top. This is a power of function notation. Yes, this is a y value, but it tells you very clearly that it's the y value that goes with x equals b. And the second one is the y value that goes with x equals a. So b minus a on the bottom is in fact the run, which means what we are looking at here is the slope formula. The reason it's getting this fancy name is that slope actually only makes sense for us to talk about if we're talking about a straight line. Slope is a constant rate of change. So if we're working on something that is not a straight line, let's say we have a curve, and we want to try and talk about how steep the curve is. We can't talk about the slope of a curve, at least not yet. We'll work on that more in calculus. But we can talk about an average rate of change, which is basically using what's called a secant line to approximate the steepness of the curve. So if we pick x equals a and x equals b, and we find 2 points on a curve, and we calculate the slope of the line that connects those 2 points, what we're getting is the average rate of change of the function. So it doesn't perfectly tell me how steep the function is, but it gives me an idea of how fast the function was increasing or decreasing on the interval a, b. This is a really big Calc 1 topic, so we want to make sure we start thinking about this now, and in particular that we recognize things like f of b minus f of a over b minus a as slope calculations. So you do want to remember the average rate of change formula, but I hope it's really easy to remember because it really is exactly the same as the slope formula. Okay, that's it for your intro stuff for function notation. Thanks.